All right, it says a particle is moving along the line, so its velocity is given. So again, its velocity, I'm always going to let myself know, ooh, they gave me velocity. For where is the speed increasing? Speed increasing. Let's go take a peek at this graph. Let's go take a peek at the graph of velocity. And I'm going to go, do I need to do the derivative of it, or do I just graph this function? Yeah, that function, since that function is velocity. So I'm going to say negative x cubed plus 2x squared plus 2 to the negative x. I'm going to graph it. So on my graph, do I really need to look at negative x values if they said that? No. And it says, when is my speed increasing? And my graph looks like this. Let me just make sure. My graph looks like this. Ish. And that's my velocity graph. If we're looking at a velocity graph, are my velocities getting bigger here? Yeah. So I'd say here is important, this red area. And then my velocities are approaching zero, so it's slowing down, my bad. So currently, my velocity is positive and it's increasing, so it gets faster. And then it's still going to the right, but it just approaches zero. Then it does what? It reverses, it's going to the left and doing what? Speeding up, because those velocities are getting bigger. It's getting more negative, meaning I'm just going faster to the left. So I'd say we need to find these regions where it's red. If my graph is looking like this, do you agree my x is going to go to infinity here? Like, this isn't chopping off. So could we say we're digging A and E right off the bat? We say we're digging A and E because time's going to infinity there. And then for this red chunk, we want to go from this x value to this x value. I don't even think we need our calculator. Oh, yeah. No, I think we do. Because they both start at... No, this one doesn't. This one doesn't start at 0, does it? Right? Wouldn't this be, they're asking from what x to what x? This right here, this green point, is when x is 0. So I'm digging A.
I think it's E, though.
Oh, it is? Okay, we're going to back that up. It's not right there. If we look at the video, oh, geez. If we look at the graph, it's like this. Good call. Shoot, zooming in is important. So we're talking about this black region and this black region. How would I find this point down here? It's a minimum. So everybody, just to remind yourselves, ready? Second trace, option 3 is minimum. They want you to go to the left of it, to the right of it, and a guess. I don't do a guess. And you're right, it's 0.177. And then I would have to go find the maximum to see where that ends, option 4. And I'd say to the left and to the right of that highest point, and I get 1.256. Guys, thanks for having me zoom in here.
Yeah, another way to do it
please.
is by getting the acceleration and then finding the zeros on each.
You're exactly right. This would be a 0 here at 2.0. Yeah. Okay. Answer is E, not A. If they're saying f prime is negative or positive between 1 and 5.
So we should get the average slope.
Yeah, let's get that average slope. Let's go see. All right. Interesting. Let's see. But notice that it says f prime is negative and decreasing for all the points between 1 and 5. So if I were to even just look at these 2 points, and if I were to do the change in y over the change in x here, do you think it'd be positive or negative? The change in y over the change in x just between these two.
Negative.
9 minus 4 would be 5 over 1 minus 2. So this would have been a negative slope. What about here? Negative. How about here? Negative. And here?
Negative.
So change of y, let me just double check that, negative 5 plus 3 over 5. But yeah, still negative. Yeah. So would you say, again, it doesn't have to be because we don't know what could have gone on. Would you agree that my f primes were negative? Right? Okay, so I'm digging A or B. And then are they decreasing or increasing? So we gotta say, are they getting bigger or are they getting smaller?
They're getting bigger.
So you're saying the change in y over the change in x. If I were to just do this one, 9 minus 4, the change in y there would be 5 over negative 1, which would have been negative 5, right? And then what about this guy?
That'd be 4.
Negative 4, right?
Ooh, it's decreasing.
Well,
Well, it depends.
wouldn't this be negative 3?
Yeah.
Yeah. And then negative 2? So what are those numbers doing?
They're decreasing.
What do you mean they're decreasing? Wouldn't they be increasing to go from negative 5 to negative 4?
He's saying the space between them is decreasing, but not necessarily.
Okay.
Say that again, bud. All right, so we're going to say my f primes were negative, but then they were increasing. We cool? We cool, peeps? Okay. T is greater than or equal to 0. The position, again, is really important to note what they gave us because this one's non-calc. It says the position was that. The acceleration, it says what is the acceleration at the point where the velocity is first equal to 0. Oh, this one has some multi-levels to it. Blah. If it says position, velocity, acceleration, let's just go find those first. If they gave us position, our velocity is going to be the derivative of it. Can we go take the derivative of sine minus cosine? Derivative of sine? Cosine, I heard it, very good. The derivative of negative cosine. Positive sine, very good. And then I'm going to just put acceleration right next to it. What the, acceleration be? That would be x double prime. Derivative of cosine? Negative sine of t. The derivative of sine?
Cos.
Yeah, the signs of SIGN could mess us up easily on these positives or negatives. Okay, it says what is the acceleration at the point, at the t value, when the velocity is first equal to 0? So you're like, all right, here's my velocity. When is this equal to 0? When is the cosine plus sine equal to 0? Could we just say another way to think about that is when is the sine equal to negative cosine? Could I just move this cosine over there? Or when does sine plus cosine equal 0? It's the same diff. When is the y-coordinate equal to the opposite of the cosine, the x-coordinate? I don't know if someone will see this in the video. Who knows? Okay, here's the deal, y'all. When is the sine plus the cosine equal to 0? Or another way to think about it is when is the sine equal to the opposite of the cosine? And this is talking about y and x, right? Whoosh. This is like me blowing up the emojis. Ha! When is the sine and the cosine equal to the opposite of each other? Twice. Happens twice. 7 pi over 4 and 3 pi over 4. Check it out. They're really ornery in this question. They say when the velocity is first equal to 0. Yeah. So is it going to happen at 3 pi over 4 or 7 pi over 4? Because we've got to go around this way. It is going to be at 3 pi over 4. Well said. So it's going to be at t equals 3 pi over 4. So that is, I think, a really hard part of this question, if you ask me. We're going to say at t equals 3 pi over 4. And then it says, what is the acceleration at that time? So I'm going to go plug in 3 pi over 4 into my t's over there for my velocity. Okay, here we go. So now we need the acceleration at, I'm just going to say we need x double prime at 3 pi over 4. Unit circle reminders. Negative sine at 3 pi over 4 plus the cosine at 3 pi over 4. Sine at 3/4 of a pi. The y-coordinate there was root 2 over 2. And then we have this negative in front of it, so I'm going to say negative root 2 over 2. Bless you. The cosine there is also a negative root 2 over 2 because that coordinate was this. That was the coordinate there. Okay, when we add those up, what is negative 1 root 2 over 2 plus negative 1 root 2 over 2 would get me negative 2 root 2 over 2. Yeah, those twos are just going to cancel, and I'm left with negative root 2. This out. These are 2022 and 2023 free response questions. So this is just more recent. Let's see how they're asking it. I think the hardest part on these actually is how they named these functions. Woof. Particle P moves along the x-axis such that its position is given here. And particle Q such that its velocity, I'm even going to put that in a different color. They gave us position and they gave us velocity. Oh, look at how they named them. They're so ugly. X sub P of T, V sub Q of T, gross. Find V sub P of T, the velocity of P. The velocity of P. Do you agree P is this top function? And they gave us the position. So what do I need to do to that to get the velocity? Take the derivative. If this was my position, I'm going to say Vp of t is really just x prime. Now, you really don't need this. If you don't need that, you don't have to take it. You don't have to write this if that's confusing you. We're just saying the velocity of p is going to just be its derivative. Y'all, we can do this. What's the derivative of 6? 0. Ooh, the derivative of negative 4e to the negative t. We love e. It's just negative 4e to the negative t times negative 1. How'd you get that, buddy? Excellent. So let's remind ourselves, ready? The derivative of e to the anything is just that e to the anything times the derivative of the anything times the derivative of the negative t, which is a negative 1. So good. It says find the velocity at time t. Guys, do we have to take that any further? No, we'd be done. Could you say that equals positive 4e to the negative t? Sure, but you don't have to. Then it says find the acceleration of q. Q is the second one. Find the acceleration at t. Let's just start with that. I'm just going to do the first sentence. The acceleration. They gave us velocity. So what would I do to get the acceleration? The derivative. I agree. So I'm going to say a sub q of t is just the derivative of velocity. Do you want to leave it like this and do quotient rule? Or do you want to rewrite it so we can do power rule? Let's rewrite it. What is this? This is the same as t to the
negative 7.
Yes. If that's the same function there, then what would the derivative of that be?
Negative 2.
Negative 2. Thanks, buddy. T to the negative third. I wrote negative 3 out front. Good call. Negative 2 t to the negative third. Is that the same as negative 2 over t cubed? I think that's going to make our lives a little easier. Why did I do that? Because it said find all times t when the speed is decreasing. Find all the times. I don't think that we're ready for that yet without a calculator. We're not ready for this without a calculator yet, so let's just end there. We will be once we get to Unit 5.
Oh, okay.
Yeah, without a calculator, we can't do that yet. So let's take that. This is as far as we need it right now. Sound good? Okay.
Would just be when the slope in the negative portion is increasing.
That's a good call. What would we be looking for? I agree. So it says, when is the speed decreasing? So wouldn't that actually be, couldn't my my velocity would have to be approaching 0 in either the positive or the negative portion of the graph? Yep, perfect. Okay. I think the hardest part on this one was just how they named these things. So many variables. Whoa. Okay, 2023 then. They said Stephen is swimming. Stephen's swimming back and forth because that's all we do. Straight line back and forth. Stephen's velocity is modeled by this. And again, I'm just going to let myself know that was velocity. Okay. Find all the times between 0 and 90 seconds where Stephen changes directions. And we do get a calculator on this one. So if I change directions, what am I doing? What's my velocity doing? My velocity is going from positive to negative or negative to positive. So is my velocity just changing signs? Yeah. So when it says give a reason for your answer, I'm going to start with that. My velocity changes signs at That's your reasoning. And we're going to go use a calculator to find it. Do we need the derivative if you're saying my velocity is changing signs? Or do we need the derivative of what they gave us, or do we use just what they gave us? What they gave us, let's go to our graph so that we can see that graph. 2.38 e to the negative 0.02 t sine, don't forget about that, wow, of pi over 56 times t. Wow. If it's saying between 0 and 90 seconds, everybody go to your window. We need to make that x max 90. And we could make our x min 0, just so that we're really looking at the window. So I just changed my x min to 0 and my x max to 90, and now I'm going to do graph. And then I'm just going to sketch something, so I've got that. I'm going to zoom in before I get myself in trouble again. Yep, okay. So it looks a little something like this. Woo, yeah? Okay. Where are we looking for this velocity graph changing signs? What do we say right there? Yeah, to positive to negative. So I'm going to go find my 0 right here. That would be a 0, y'all. So let's do a little second trace, option 2. We got to get to the left of it, whoa, which is going to be really hard for me. Lots of clicking. And then we got to get to the right of it. What'd you all get for your 0? Oh, 56. That is a very nice whole number. 56.
Yeah, because it's pi.
Then it says, hey, go find his acceleration at t equals 60. We get a graphing calculator. Show the setup for your calculations and indicate units of measure. And then is the speed doing something? Okay, find his acceleration at time t equals 60. If they gave us velocity and this is calculator active, what could I do to find the acceleration using my calculator? Math 8, dy dx, exactly. So you guys, I'm just going to say, I'm going to go find v prime of 60. That is just my acceleration. V prime of 60. So I'm going to go to my home screen, and I'm going to say math 8 of that function, 2.38 e to the negative 0.02 t sine of pi over 56 times t. And where do they want this derivative when x is 60? Negative 0.036. If you don't give them 3 decimals, they're going to be angry. And then it says, is Steven speeding up or slowing down at 60 seconds? Guys, this circles back. Things are speeding up and slowing. Speeding up when the velocity and acceleration have the same signs. Slowing down when the velocity and acceleration have opposite signs. So I already know I already know the acceleration at 60 seconds. Could I go find the velocity at 60 seconds? So I'm going to say my velocity at 60 seconds. How could I get that if they gave me velocity? Plug it in. I'm going to be on this home screen, 2.38. I wonder if I go up here, if I just delete the derivative, if it'll leave the rest of it. I'm going to try, people. I'm going to try. Nope, it sure doesn't. Okay, tried. 2.38 e to the negative 0.02x. You got it? You did? Oh, good. My calculator is lame, but I'm glad that yours worked. That's a time saver. Pi over 56, and then we have times t. Nope, times 60. Did you get a negative 0.15? Yeah? Okay, make sure that you write 3 decimals. Negative 0.160? Is that what that would be?
You need to put 60 to the 0.02x.
Oh gosh, I sure do. What a goober. Thanks. You know what that means. Candy lob times 60. Oh wait, that's so funny. It's still giving us the same value. Ish, because again, we're dealing with such small or big numbers. Okay, negative 0.16. Oh, is that right? Okay, speeding up or slowing down?
Speeding up.
Speeding up because?
Slow signs are equal.
Because both acceleration and velocity have the same sign at when? At t is 60. That's huge to write.